Suppose I want to evaluate log base 5 of 16. If this said log base 4 of 16, this would be no problem whatsoever. I know that 16 is 4 to the second power. I can rewrite it like that. And I know that a logarithm is the exponent that I have to put on the base in order to get the number. So the value of log base 4 of 16 is 2, no problem at all. Unfortunately, that's not what it says. It says log base 5 of 16, which means what power do I have to put on 5 to get 16? Well, I know that 5 to the first power is 5, and I also know that 5 to the second power is 25, but 5's not enough, and 25 is too much. I want, what power do I need to get 16? So it's something between 1 and 2, but that's not very exact. I'd really like to know exactly what power I need to evaluate that logarithm, and that I just can't tell. I don't know. That's not something we can do easily. So what am I going to do if I want to evaluate this? Well, here's what I'm going to do. I'm going to give log base 5 of 16 a name, because it's easier to talk about things when they have names. So log base 5 of 16, I'm going to name x. That's a good name for things I don't know. Well, I still don't know what it is, but I can do some stuff with this. It's an equation now, so I can rewrite it in its exponential form. Here's my base, is 5. Here's my exponent from over here. This is my exponent equals the argument of the logarithm, the other number that I didn't use yet. So 5 to what power gives me 16? Well, duh, I knew that's what I wanted, and I still don't know what it is. So what can I do with an equation? Well, I can do the same thing on both sides of an equation. So what I'm going to do on both sides of this equation is take a natural log. Natural log of 5 to the x is natural log 16. And that I can do that because anytime I do the same thing on both sides of an equation, it maintains the equality. Those two quantities are still equal. On the left now, I can apply one of the properties of logarithms, which is I can take the exponent and bring it down in front and multiply. So I can say x times natural log of 5 equals natural log of 16. Well, natural log of 5 is a number. I don't know what it is, but it's definitely not 0. It's a number just like 3 is a number. So I can divide by it. So I'm going to divide both sides of my equation by natural log of 5. And again, that's just a general equation solving thing. I can divide both sides by the same number. But look what that does. That gets me the x by itself. And this is what I wanted all along. I wanted the value of x, the value of log base 5 of 16. I get x equals natural log of 16 divided by the natural log of 5, which is something that we can do on the calculator. When you use the calculator to do this, probably it's going to want this 16 and the 5 to be enclosed in parentheses. Many calculators are pretty forgiving about parentheses. This is not something it will forgive you for. You want to make sure that you close up the parentheses around the 16 before you divide. Otherwise, it'll tell you the right answer to a different question that you don't care about. So this is one time you do need that closing parentheses around whatever's in the numerator. Natural log of 16 divided by the natural log of 5 is 1.72 rounded to 2 decimal places, which is between 1 and 2, which I knew is how it ought to turn out. So I believe that. There's the value of log base 5 of 16. Here's an interesting thing. Back up here, when I took the natural log on both sides, I could have used any base. I could have used any base I want. If you want, you can use a common log, logarithm base 10, up here. And that means down at the bottom, I'm going to end up with x equals log base 10, log, 16 divided by log base 10 of 5. Perfectly well allowed. And wouldn't you know, it's going to turn out the same. If you use log base 17, top and bottom, you'd still get the same thing. I don't know why you do that because it's hard to do on a scientific calculator, but you could. So whatever base you want to use, but use either a natural log or a common log, since they're easy to do on a calculator. And we've found the answer to the question. And we've also found something that we can say more generally. If I want to take log with some base, we'll call it b, generic base, of a number, which I'll call a, I can use this technique. You don't have to go through that whole process ever again. We've done it once, and we saw how it ended up. How did it end up? It ended up with, I can take the log with some other base of my original number and divide by the log with that same other base of the original base. We're going to call this the change of base formula. And we can use that all the time. For example, if I want to evaluate what's log base 6 of 52. Well, we could go through that whole thing again, or we can just look at where we ended up here. Log base 6 of 52, the change of base formula says that's the natural log of the number, 52, divided by the natural log of the original base, which is 6. That's something that's pretty easy to do on the calculator. Again, make sure you close up those parentheses on the top, and we end up with, rounded to 2 decimal places, 2.21, and done.